DLT technology. In this lesson, we'll get deeper into the world of DLT technology, which is the distributed ledger technology behind blockchain. To better understand this technology, we'll start by defining what centralized registries are. A registry, or database, is considered centralized when the data is stored on one or a few servers, usually located in a specific geographical area. In a typical configuration of a centralized registry-based system, the database is hosted on a central node or server. Peripheral nodes can access it, but are not allowed to modify it. Most of the applications we use on a daily basis, such as Facebook, Twitter and LinkedIn, operate with this centralized architecture. However, this architecture has some disadvantages. The first disadvantage is centralized governance. This means that only the entity that manages the central node has decision-making power over how the database is modified. The second disadvantage is the so-called single point of failure. In other words, if the central server suffers an attack, the data could be compromised or the entire system could be interrupted. In opposition to this, distributed ledger technology offers an alternative model. In DLT, there is no dominant node, all nodes have the same rights. Each node in the network then has an exact copy of the ledger, which increases resistance to attacks. In the DLT scenario, the blockchain is a specific category. This means that while all blockchains are forms of DLT, not all DLTs are necessarily blockchains. To be more precise, a blockchain is a form of DLT that is distinguished by a structure made up of blocks linked in sequence, each containing several transactions. An example of a DLT that does not fall into the blockchain category is the Tangle technology adopted by IOTA. Tangle is an alternative to traditional blockchains. Tangle was designed primarily for the Internet of Things, IoT, aiming to guarantee fee-free transactions and superior scalability compared to conventional blockchains. Let's take a closer look at how the Tangle operates, unlike blockchains, where transactions are accumulated in blocks and added in sequence. On the Tangle, each transaction is directly linked to two previous transactions. Whenever a new transaction is made, it validates the two transactions to which it refers. This integrated validation approach eliminates the need for miners or other participants who, as we will explore later in the course, are typically responsible for validating transactions on traditional blockchains.